Good morning, everyone, and welcome to the class. This is Circular Dynamics lecture number 13. Well, we are almost at the end of this chapter. This chapter includes circular dynamics, which is almost over, which is already over, in fact. And we were trying to discuss certain points which has both circular dynamics and work power energy coming in between. Well, as you remember, in the last lecture, if I go back, we had discussed two cases. What will happen depending on the speed at the lowest point. And we had seen that if the speed at the lowest point, point A, is exactly equal to root of 2gl, the particle will go to the middle point, the diameter point B, and then it will stop there. Tension and speed both becomes zero, and then it will keep on moving in that semicircular half. If my speed at the lowest point is less than root 2gl, then it will not reach the point B. It will stop somewhere in between. Speed will become zero, but the tension will not become zero. It will keep on moving in the lower half. We also had seen the example when we had given a speed less than root 2gl. We had given a speed which was exactly equal to root of gl, and we saw that it only goes up to an angle 60 degrees, it stops there, and then it comes back. So we have seen one particular speed at root 2gl. What happens if the speed is less than root 2gl? What will happen? Now, the most general question, or the next question that will come in our minds, which must be already there. What will be the next case? Case number 3. What would be case number 3? What would be the next case? The particle can reach this point if the speed is root 2gl. If it is less than root 2gl, it will end somewhere at a lower point. The next question that would obviously come to our minds when I think about this would be, what will happen? What will happen if the speed at the lowest point, point A, is more than root 2gl? Now, you can all understand that if the speed at the lowest point is very, very high, very, very high, very, very high, very, very high, it will obviously reach the highest point, which I think was C, and then it will keep on going up, down, up, down, up, down, up, down. Here we must understand that I have seen that there is a speed which makes it reach the point B, and that speed is root 2gl. Now what I must think on is, what is the speed? What is the speed that is required at the lowest point, which is point A, so that it just reaches the highest point C? And that is what I must be thinking about right now. I know if I give it root 2gl, it will reach the point B. If the speed is more than root 2gl, it will keep on going higher. What must be the speed given to the particle, to the bob, at the lowest point, so that it just reaches the highest point, and that is the only point of concern right now. When it reaches the highest point D, or highest point C, Then it will keep on moving in this complete circle, and we call it as it has completed looping. It is looping. It is moving in a complete vertical circle. We can call it. The term that we use is looping. Looping. Loop. Loop. Everyone knows what is a loop. Loop is a complete circuit. Loop. That is what we are thinking about. That is the next point. Let me have a look at what was the number of the last point. The number of last point was 9. So the next number is 10. The next number is 10. And the next number is condition. Condition for completing. Condition for completing the circular path. Condition for completing the circular path. This is one way you can understand this, or you can write is condition for looping. When will it loop successfully? Or you can say it reaches the highest point C. We have to find out the condition that it reaches the highest point C. What do you think could be the condition that it reaches the highest point C? Now, most of you might think that, sir, if it has to reach the highest point C, the speed when it reaches the highest point, if it is more than 0 or exactly equal to 0, goes up there, it will slow down, but it will keep on going up, slowing down. If it just reaches the highest point, sir, if the speed just becomes 0 at the highest point, if the speed just becomes 0 at the highest point, well, sir, that would be the condition. If it somehow reaches the highest point and the speed becomes 0, it will complete looping. That is the first thought that comes to our mind. Well, that thought is not completely incorrect. It happens in one case, but that case is not this case. Now, what you have to understand, and what I will write it as note in your notebook, is point number 10A. Now, to understand, if you remember these points, you will be able to understand what is the condition that it completes a loop. Number 1. In the upper half, that you have to remember, in the upper half, if tension T, in the upper half, if tension T becomes 0, remember what I said, tension T never becomes 0 in the lower half. So I never have to worry. I never have to worry about this particle leaving the circular path in the lower half. But as I said, tension can only become 0 in the upper half. Now, if the tension becomes 0, tension becoming 0 means the string gets slack or the string breaks. When the string becomes slack, there is no tension in the string. And you remember why this body is completing or making circular motion? It's because of tension in the string. If the tension in the string becomes zero, it will no longer follow a circular path. And so, if it does not follow a circular path, na, 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 if it does not follow the circular path, it will never reach the highest point because it is not on a circle. Now it will have a different path. What is that path? I will also tell you that. If the in the upper half, if the tension becomes zero, the particle, oops, wrong color. The particle leaves the circular path. The particle leaves the circular path and hence it cannot reach the highest point. Number B, 10 ka B. Therefore, the condition for completing looping, condition for completing loop is tension at the highest point, which is point C, should be greater than or in the worst case equal to 0. That is the condition for looping. Tension at the highest point should be greater than or equal to 0. I can now understand this as like this. If tension at point C is greater than 0, if tension at point C is greater than 0, it completes loop point D. If tension at point C is exactly equal to 0, it just completes the loop. Now, when I say just completes the loop, I mean it just reaches the point C. I hope you understand the difference between the two terms. One is it easily completes the loop, easily goes. If tension at point C, which is the highest point, is greater than 0, it completes the loop very easily. But if tension at point C is exactly equal to 0, we call it the condition of just completing the loop. We understand this? Can I have some raised hands from everyone in the class up till now that we have understood whatever we have discussed? Whatever we have discussed. What about the offline class? Can I have some response from the offline class? That we have understood this. Okay, that is great. I will write one more point and then, okay, what I'll do is I'll just write one more point here and then I will give you time to note this down. Now, most of you would think, as I said, sir, what about speed? What about speed? Why is the condition not speed becoming 0? And why is the condition not tension becoming 0? I have partly answered the question here. I have told you that if tension becomes 0, bacha, it will not follow circular path. Forget about completing it. So the condition has to be tension T becoming 0. If tension T becomes 0, it leaves the circular path. But now we say, sir, what about speed? What if the speed becomes 0? Yes, speed becoming 0. But now we'll write another point that will clear that out in the upper half. And please remember this, in the upper half, both T and V. I hope you understand the meaning of T and V. T is tension, V is the speed. Can both become zero? Yes. Can both become zero? But, and this is an important but in the upper half, T becomes zero before V. T becomes zero before V. So it's like a race. Who will become zero first? Both T and V are contenders of becoming zero first. They both want to become zero first. But there is only one winner here. In the lower half, if you can recollect, in the lower half, tension has no chance of becoming zero. It cannot become zero. Tension cannot become zero. If the speed is exactly equal to root 2 GL, both of them come first because both of them become zero at the same time. T cannot win in the lower half. Both of them win when the speed is root 2 GL. But as soon as the speed becomes more than root 2 GL, speed cannot become zero first. It's the tension that always becomes zero first. Can I have some raised hand that we understand this? That in the upper half, both tension and V can become zero, but here tension will become zero first before speed becoming zero. And therefore, an important therefore, this implies, therefore, condition of looping is tension should be greater than or equal to zero, because if tension is greater than or equal to zero, speed will always be greater than or equal to zero. Speed cannot become zero without tension becoming zero. Tension will always become zero first. In this particular case, when the what? When the particle is in the upper half of the circle, I'll give you a minute, 2 minutes to note this down. If you have any doubts, you can always come up to me. A minute, 2 minutes. Well, I hope everyone has noted this down. What is the condition of looping? So the primary condition of looping, as you all can see, is tension at the highest point should be greater than or equal to zero. But if you recollect, what we were doing where was we were relating everything with the speed at the lowest point. So now we will write the condition when this happens. What is the speed at the lowest point? Again, we will not go into deriving this. The part of deriving this is not a part of NEET, so I will not do it. We'll just write a condition of what should be the speed at the lowest point. For completing looping, for completing the loop, speed at the lowest point A should be greater than or equal to root of 5 GL. So now we have another value coming in. For completing loop, speed at point A should be greater than or equal to root 5 GL. I'll not derive it. We'll just note it down. Oops, wrong color again. The next point G, if the speed at point A is greater than root 5 GL, it completes the loop easily. Tension at point A will be great. Uh, speed at point A is greater than 5 root 5 GL. Tension at the highest point C, I've written A. The tension at the highest point C will be greater than 0. Successful completion of loop. Successful loop. It will complete the loop very easily. But if the speed at point A is exactly equal to root 5 GL, tension at point C becomes equal to 0. Tension at point C becomes equal to 0. Velocity at point C becomes equal to root of GL, and it just completes the loop. Here you can also add, speed at point C will be greater than root of GL. I must also note down terms in terms of tension at point A. When speed at point A is greater than root 5 GL, tension at point A is greater than 6 mg. How do you get all these results? We get all these results by the equation that we have already written. I'm not going to derive this because that will be just a waste of time. I'm just giving you these as statements that you could remember. If I get time between your 11th and 12th standard, I will derive these if possible, if you need it. Else, the derivation would be done in the JEE wala class. You can have a look at those lectures and you will benefit from them. So, the last case is when velocity at point A, speed at point A is exactly equal to root 5 GL. In that case, tension at point A is exactly equal to 6 mg. What are the things that you must remember? Two values have come to us. One is root 2 GL, one is root 5 GL. Root 2, root 5. Root 2, root 5. Less than root 2 GL, it remains in the lower half. Nothing said, nothing done. Exactly equal to root 2 GL, it reaches the middle point B, the diameter point B. Tension and speed both will become 0. If the speed is exactly equal to root 5 GL, it reaches the highest point. And at the highest point, tension becomes 0, but the speed does not. Because speed cannot win in the upper half. It always comes second in becoming 0. If the speed is more than root 5 GL, no worry, my dear friends, it will complete the loop easily. Tension never becomes 0 anywhere. Because the only point that tension is in danger of becoming 0 is the higher points. If it does not become 0 at the highest point, it never becomes 0 anymore. One case remains now. One Case remains. What is the case? We have done exactly equal to root 2 GL. Case number 1. Less than root 2 GL. Case number 2. Case number 3, which is the condition of looping, I will just write it as case number 3. This is case number 3. This is case number 3, condition for looping. Case number 3. This is case number 3. And case number 3, speed at point A is greater than or equal to root 5 GL. This is my case number 3. Case number 3. Then comes my last case, which encompasses everything that can happen to this particle. What, my dear friends, would be case number 4? Case number 1, root 2 GL. Case number 2, less than root 2 GL. Case number 3, greater than, easily complete loop. Equal to 5 GL, just complete loops. What would be the last case? What would be the last case? My dear friends, what would be the last case? Case number 4, anyone? What would be the last case? I think this is point number 11. Case number 4. Anyone? Anyone could give me an answer for this? What would be the last case? Anyone from the offline class? Anyone from the online class can give me this answer? And the last case is root 2 GL is less than speed at point A is less than root 5 GL. That means the speed lies between root 2 and root 5 GL. It is greater than root 2 GL, but less than root 5 GL. That would be the last case. And what will happen in this case? Anyone? What will happen in this case? What will happen in this case? In this case, what will happen? In this case, somewhere between B and C, depending on how much is the speed. It could be 2.5 root over 2.5 GL, 2.7, 3, 4, 4.5, 4.7, 4.8, whatever. It should be between root 2 GL to root 5 GL. In this case, somewhere between B and C, tension will become equal to 0. Remember this, tension will become equal to 0. If tension becomes equal to 0, particle leaves the circular path. And follows projectile, the chapter number 2 wala motion, projectile motion. It becomes a projectile now. It does not move in a circular path. It becomes a projectile motion, which is motion under gravity. It follows a projectile motion. Do we understand this? Can I have some raise hand that we understand this? Everyone in the online class as well as in the offline class, can I have some raised hands from you guys? We have covered all types of cases. I'll give you time to note this down. 4 cases. You can call them 5 as well. I'll just write them in short. We have explained it completely. I'll just explain them, write them in short. In shorts. In short. In short. Point number 1. The speed at point A is less than root 2 GL. It remains in lower half. It remains in lower half. Speed will become 0. Tension is always greater than 0. Tension never becomes 0. If speed at point A is exactly equal to root 2 GL, I hope everyone is writing. It reaches B. T at B is equal to 0. V at B is equal to 0. If root 2 GL is smaller than VA, is smaller than root 5 GL, T becomes 0 in between B and C. Velocity is always greater than 0. It follows a path of projectile. Number 4, speed at point A is exactly equal to root 5 GL. Tension at point C becomes equal to 0. Velocity at point C becomes equal to root of GL. Just complete loop. Last but not the least, speed at point A is greater than root 5 GL. Tension at point C is greater than 0. Velocity at point C is greater than root GL. It completes the loop successfully. No problems. I'll give you time. Note this down. A minute. Note this down. If you have any doubt, please come. I hope all of you have noted this down. 5 cases, and this covers everything that can come in your exam ever. What I'll do is I'll just now show you something that is given to you in notes, and I'll ask you to note them down in terms of diagram. The more you write them different ways, the easier it becomes to understand them later on. Here it is, what we were discussing: motion in a vertical circle. As you can see, this is the center O, this is the lowest point A. If anywhere at any angle theta, we have also discussed that the equation will be equal to T will be equal to mv square by L plus mg cos theta. Do we remember this? Can I have some raised hands from all of you in the class that we remember this, sir? So you can draw this diagram and just write this equation once again, if you don't remember it, once again, so that it becomes a part of our memory forever. We should not lose it at any point in time. Please note it down. Draw the diagram. Do it. I hope you have noted it down. We have already done it. This is just to remind you the points once again. The next point that I want to remind you is that as soon as you go up, tension will keep on decreasing. Tension will keep on decreasing with increase in cos theta, because cos theta is a decreasing function. Minimum tension will be at the topmost point. If tension minimum is at the topmost point is greater than 0, then this is the condition of completing the circle. Tension at the topmost point is greater than or equal to 0. We have already seen this point. Condition for looping is tension at the highest point must be greater than it easily completes the circle, or exactly equal to 0, it just completes the circle. That point should be absolutely clear. Can I have some raise hand that we understand this? Everything has been underlined once again. We are spending so much time here because I want you to be absolutely certain of what we are doing here. What we are doing here, you should be absolutely certain. Are we there, everyone? Waiting for your raise hands. Bacha. This point is absolutely clear. Online class is clear. What about the offline people? Are we there? Yes, we are all in it together. Well done. Let us move ahead. I think we have already noted down time to move ahead in life. Time to move ahead in life. And then we come to the point where we understand it in terms of velocity at the top. Velocity at the top for completing the loop. And this is in blue dabba, the blue dabba, velocity at the top in the blue dabba. Blue square, blue rectangle, whatever you call it. This is the condition for completing the loop. Now comes the red dabba. Red dabba is the condition of completing the loop at the lowest point. At the lowest point, the red dabba, your speed or velocity magnitude must be greater than or equal to root 5 GL. The highest point, the velocity must be greater than or equal to root of GL. I hope everyone understands this. I again want you to raise your hand so that I understand this, that the effort that we are putting in is going in the correct direction. Can I have some raised hands? Can I have some raised hands? Online students, offline students, everyone. Do you understand this? Online students are there. What about the offline guys? Offline students, my students in the class. Are we there in it together? Yes, we are in it together, and that takes us ahead. Offline students, you also have a mic. Instead of raising your hand, you can say, yes, sir, we understand. Use your mic. If you can't go up there and say, raise your hand. If you can't go up there and raise your hands, you can just say it on the mic, and that is good enough for me. That is good enough for me. Now, what I want is that you should be able to draw these diagrams so that things become absolutely clear. This is figure number 1. In figure number 1, the speed at point A, the lowest point is root over 5 GL. They have written all the equations, and from there you got tension is 5 mg, centripetal acceleration 5g. It's not grams, 5 into g, acceleration into gravity. Tangential acceleration is 0. Total acceleration is 5g. This is case number 1 when the speed is exactly equal to root 5g. Case number 1, figure number 1. Figure number 2, they have given it root 3gl, just the intermediate velocity between 2gl and 5gl. And you can note down these quantities. Now, the speed at the lowest point is root over 5gl, and then they have told you if the speed is root over 5gl, what happens to the point B, how much is the speed at point B? The speed at point B comes out to be root 3gl. So I would like you to note it down. With the speed at the lowest point, you can write out the speed at the point B. Lowest point, it is root 5gl. At the middle point, it becomes root 3gl. And when it goes up to the highest point, it becomes root of gl. Please note it down, everyone. The tension would be 3 mg, centripetal acceleration is 3g, tangential acceleration is g, net acceleration is g under root 10. So all points derived from equations. If you can write them down, that would be good enough. I'll give you a minute to note it down. This is the case where we have given root 5 GL at the lowest point. What happens at point B? A minute. I hope everyone is noting it down. Everyone is noting it down. These are the case where the velocity at the lowest point is just enough for looping. Just enough for looping means velocity at the lowest point is root 5 GL. What happens at point B, C, and point D? We'll just draw the 4 diagrams and to understand what is happening where. I hope, I hope, I hope, I hope that you have written it down. Then we move on to diagram number 3, figure number 3. What happens at the highest point and what happens at the point D? At the highest point, potential energy is 2 times mgl. Velocity becomes exactly equal to root of gl. Tension becomes 0. Centripetal acceleration becomes g. Tangential acceleration becomes 0. Total acceleration becomes g. Well done. I hope you understood this. If I come back to point D on the left hand side, everything is similar to point B. One is on the right hand side, the other is on the left hand side. Both the points are symmetrical and hence the values are equal. The directions are not vectors, directions are not, but the values are equal. I hope you understand this. Can I have some raised hand that we understand what is happening at the various points when the speed at the lowest point is root of 5 GL? Do we understand this? Can I have some raised hand? Raised hands will give me more confidence that we are on the same page. Offline students, online students are there offline. What about my offline kids? Kids who are in the class working hard. Are we there on the same page? Do we understand this? Have we drawn the diagram? Well done. Everyone seems to be on the same page. I'll give you a moment to see and to write it down because I'm only left with 2 or 3 minutes in the class. And I just have to do one more thing in between point, and then we are done with this class. So give you a moment to write it down. I hope we have written these equations, and then comes the last case. In between points, what happens at the in between points? And just remember this equation and you would be good enough. At any angle theta, if this angle is given as theta, potential energy is this much, speed at this point will be this much. It looks very complicated, but this is the result that you get from the equations that I have already given you, and I solve it. Tension becomes this much, centripetal acceleration becomes this much, and the tangential acceleration becomes this much. If you have time in the examination hall, which I doubt, you have to do 45 questions in an hour for physics. Too tough. But the question will not be that difficult. I've always insisted that NEET exam, especially physics, even biology and chemistry, are not about how much you understand. It's more about, do you remember it? Something in your, I mean, I hate biology. I hate biology. I remember in standard 10th, I tell you, I got more marks in biology than I got in maths. Biology in 10th standard, I scored 100 out of 100. In maths, it was 99, so 1 mark less. So I should have taken biology in 11th standard. Probably I should have. Looking at the circumstance, I would have been a big surgeon right now. May not be teaching. Anyways, that's a different case. I could not dissect the tadpole they had given to me. Some frog or tadpole, I had to dissect it. I could not even pick up the knives to dissect it. I said, this is not meant for me. The second reason was my drawing was awful drawing. Still, my drawing is awful. But I can somehow manage engineering drawing because I'm good at engineering. I'm good at using my brain. So what I feel is, when what they're asking you NEET exam, and I'm not talking about doctors in general, I'm talking just about the reason what they give you some part of the body and then ask you what is this. There's nothing to understand there. What is this? I mean, if you know the name, you know the name. If you don't know the name, you don't know the name. That's it. If I know that the length of the small intestine is this much, I know it. I can't understand it. NEET exam, just about remembering. Remembering. It's not a test of your physics, not a test of your understanding. It's a test of your brain. How much does it remember? You must be knowing that. So biology students, different parts of brain do different stuff. One part of brain is your hard disk. Things are stored. I don't know where it is. NEET exam, test that part of your brain. Your hard drive. It does not check your processor. Even JEE Mains does not check your processor. JEE Advanced to a certain level checks your processor. Check your processor, they don't check your hard disk. NEET exam checks your hard disk. And therefore, will not get question that will puzzle you into. Last year was a aberration that we got some difficult question in physics as well. It's difficult for all. Generally speaking, the questions are more about how much do you remember, and that is why I keep on insisting on the same thing and keep on telling you the same thing once, twice, thrice, 4 times, 5 times, 6 times, so that it gets in your hard drive and you store it in some folder where you can retrieve it when it is required. And that is how I will end today's class here. This chapter is almost over. Next class, we will wind it up with 1 or 2 problems. And then, if time permits, I'll do one more case. Again, that case may not be a part of your NEET curriculum. It may never come. But if it comes, then you will be at the forefront and you will be scoring in those. Take care. Have a good day. I hope you enjoyed the class. Till the next time when you meet, take care. Stay home. If you're in hostel, stay safe. Get vaccinated. I'll see you on Saturday. Bye-bye. Have a nice day.